So good day everyone. Today we're going to be treating a new topic called Developpement Limité. For those doing math informatique, this is just another topic in analysis. And then for those doing ST, SM and the like, this is just another topic in mathematics. They are all called mathematics, but just to distinguish, because for those doing math informatique, you have your analysis and you have your algebra, so you know where this topic is going to come from in your second semester. So what's development limit? We say that a function f has a dl. Instead of writing development limit all the time, I can just denote it as dl, or say it as dl. So we say that a function has a dl à l'ordre n with, if there exist constants a0, a1 up to an, any constant, such that, now we're going to be such that, this is the definition, the formula for the development limit, such that f of x will be equal to a0 plus a1 x minus x0 plus a2 x minus x0 raised to the power of 2 plus an x minus x0 raised to the power of n plus xn of epsilon of x minus x raised to the power of 2n, where the limit when x approaches 0 of epsilon of x is equal to 0. Now you might be asking, what exactly is this epsilon of x? Well, epsilon of x in this case, the development limit, is the remainder of the dl, the remainder after calculating what is left after calculating. We don't have to write, that's the good part of epsilon of x, we don't have to write that exact remainder. We just denote it as epsilon of x, but as long as the limit when x approaches 0 of that epsilon of x is equal to 0. So now the a0 plus a1 x minus x0, it looks kind of familiar. Maybe we would say a polynomial. Well, this, I'll just define the terms that we have here, all of them, so it will be clearer for us. So if I have this a0 up to an x minus x0 plus a2 x minus x0 raised to the power of 2 plus an x minus x0 raised to the power of n, we call this the partie régulière du dl. This is the part where you always see, the part where you actually have to calculate, so it's like the main part, so we call it the partie régulière du dl. And then I'll write the other one just here. The n that you're seeing around the n is what we call the l'ordre du dl. The l'ordre du dl is, let me say you're asked to, for example, you are asked to calculate the dl of a certain function. You need where to stop, right? I mean, if you're telling me to calculate the dl of a certain function, except if you tell me to go to the order of n, but if you tell me to calculate the dl of a function, you should also tell me where to stop, right? So in that case, the n helps us, like if you're asked to calculate a development limit, they'll tell you at the order of 1 you stop at 1, or maybe 2, or maybe 3, depending on the question you're given, which of course we are going to try in examples and exercises that we're going to do, which is my favorite part of mathematics. So this is the formula And this, if you notice, since we're talking about it being the sum of that, it's we can summarize it as, let's do it here. We can summarize it as the sum of e equal to 0 up to n of ae x minus x0 n plus x epsilon of x minus x0 raised to the power of n. Yeah. So this is the definition of development limit. Now, just it's very important, like what I normally tell my students is, it's very good if you actually write this down in your record book, so that from time to time you can look at it, and before you know it, the formula is already mastered into your head, if that word exists anyway. But yeah, so there are different methods of calculating DL, which we're also going to talk about, and we'll try out examples. There's the Mac-Laurin-Young formula, which works when we are talking about the voisinage to 0, when x is equal to 0. Yeah, we're going to treat it now, so let's do this. The Mac-Laurin-Young formula, I did that dash and Young so that I don't have to write the avec res de Young, but it just, this statement means Mac-Laurin avec res de Young formula. Often, especially at this stage, we calculate DL mainly over voisinage de 0. I mean, like now that we are just in the beginning of the topic, we calculate DL mainly over voisinage de 0, and this method is easier to realize, and using the Mac-Laurin avec res de Young formula, it allows us to write the DL à l'ordre n, the n that you'll be given, over voisinage de 0. That's when x is equal to 0. Okay, so let's just go straight to the formula. Yeah, so f of x, which we're going to also do examples, so it becomes, hopefully we get to understand it. F of 0 plus x over 1 factorial f prime of 0 plus x squared over 2 factorial f prime of 0 plus x raised to the power of n over n factorial fn of 0 plus x n epsilon of x, where the limits when x tends to 0 of epsilon of x is equal to 0. So this is the formula for the Mac-Laurin avec res de Young. And also, the limits when x approaches 0 of epsilon of x being equal to 0 is actually important for you to write, because since you're not going to be writing the remainder, we should look for a way to represent it. So this is how we get to represent it. So in this case here, you notice that we have f prime of 0, we have f prime of 0 up to fn of 0. The aim of this particular one is that we have to keep deriving the function up onto the order that we are given, and then we apply it to the formula. So here we see that we have to now be looking for f of 0, we are looking for f prime of 0, f prime of 0 up to f of n 0 per depending on when you put your give in the end, remember, like we said the other time. And from this formula also we can see that the f of x is divided into two parts. It's divided into the polynomial of degree n and then a remainder which we call the rest-du-Young. Yeah, I'm going to show us that. From here, all this is the polynomial. It's a polynomial, so we call this the polynomial of n degree. And then this remainder, we just call it the remainder, or in French the rest-du-Young. So now we're going to start with like two examples to show us just how this particular method works, and subsequently we'll talk about in our next video. We'll be talking about the function usual of DL. We'll talk about the operations used in DL, and from there, when we're done, we go to the best part. I love that part, actually tackling exercises. So let's go with examples under Mac-Laurin. So we're asked to, in this case, determine the DL of voisinage to 0 and l'ordre n equal to 2. So in this case, they've given us a function, and they've also told us that we should stop at n equal to 2. The first thing we'll do is that the first step is we are going to put down our formula of that's Mac-Laurin-Young formula, so we actually know where we're going to start from, where we're going to end, what exactly we are looking for, just to give us that insight on what we're doing. So using the Mac-Laurin-Young formula, f of x is equal to f of 0 plus x over 1 factorial f prime of 0 plus x squared over 2 factorial f prime of 0. Since we're stopping at log 2, we'll just be left with this. There, of course, the limit when x tends 0 of epsilon of x is equal to 0. So now what exactly are we looking for in this formula? We are looking for f of 0, f prime of 0, and f prime of 0. And when we've gotten these three things, we just replace it back into the formula, and that's all. Yes. So let's solve this exercise. Example, okay? So remember, we are going to l'ordre 2, and l'ordre of 2. Okay, so we know that f of x is equal to 1 over 1 plus x. So that f prime of x, deriving this, when we are deriving a function of x raised to the power of n, it gives us this. Now deriving in this way, it's kind of not going to really help us, things like that. So I advise we actually just change the fraction and make it raised to the power of -1, because this is the same thing as raised to the power of 1. So we just change it to 1 plus x raised to the power of -1, and we derive it. So deriving this, we'll be having -1. That's using this formula that our x here is 1 plus x, and then our n is -1, -1, -1, -2. Then the next thing is f prime prime of x. For f prime prime of x, you already have that, right? So all we do is just to derive it the second time. So if applying the same method, we have -2 times -1, that's 2. Then 1 plus x, -2, -1, that's -3. And that's it. So, and we have our derivative f prime of x and f prime prime of x, and as well as our function f of x. Now, what we are looking for f of 0, f prime of 0, and f prime prime of 0. So what we do is to replace our x, that's the next step, the third step, replace our x with 0. So our first step was putting down the formula and knowing exactly what we're looking for. Second step is now going through the operation, deriving up to the order that you are given. The third step is now replacing them with 0. So anywhere I have x, I replace with 0. In this case, I think it's better if we actually change it back to the fraction part so you get to see it. So f prime of 0, this is the same thing as -1 over 1 plus x raised to the power of 2. So if I replace this with 0, I'll be left with -1 all over 1 plus 0 raised to the power of 2, that's -1. And then f prime prime of 0 is the same thing as, I should do that here, okay? So I have 2 over 1 plus x raised to the power of 3. So this is going to give us, if I replace this with 0, I'll be left with 2 over 1, which will give me 2. So then this is no longer necessary. Now back to our main function f of 0. If I replace this with, which I already did, we have 1 over 1, which will give us 1. So that means our f of 0 is 1, our f prime of 0 is -1, and our f prime prime of 0 is 2. And that's all we'll do. All we have to do now is just replace it in the formula that we have. So I know f of x is equal to f of 0 plus x over 1 factorial f prime of 0 plus f prime prime of 0 x squared over 2 factorial plus x2 epsilon of x, where the limits when x turns over 0 of epsilon of x is equal to 0. So our final answer, our f of 0 was 1 plus x over 1 factorial f prime of 0 -1 plus x squared over 2 factorial f prime prime of 0, we got 2 plus x squared epsilon of x, where the limit when x turns over 0 of epsilon of x will give us 0. So let's rearrange our final answer. So we'll have f of x will be equal to 1 plus -1 and plus, so this becomes negative. So negative x over 1 factorial is 1, so that's x. 2, this 2 will cancel this 2, because 2 factorial is 2, 2 times 1, and we'll be left with x squared, so this will be x squared. And since that's where we're stopping, we're having x squared epsilon of x, where the limit when x tends 0 of epsilon of x is equal to 0. And that is your final answer. Kind of, that's basically how it works. So we'll try out another example just so we can be clear. Probably we might use that again, so I'll leave it. So we have a second example. We have a different function, 1 plus x alpha. In this case, same thing. We should calculate the DL and load n equal to 2. Same thing like we did the other time in the previous example. We put in our formula. That's our first step. Our first step, we put in the formula. So I should make it clear this time. First step, put in the formula. So we have f of x is equal to f of 0 plus x over 1 factorial f prime of 0 plus x squared over 2 factorial f prime prime of 0 plus x squared epsilon of x. I'm stopping at x squared, remember, because of our order of 2, where the limit when x tends 0 of epsilon of x is equal to 0. That's the first step, knowing what we are looking for. So in this case, we know that we are looking for f of 0, f prime of 0, and f prime prime of 0. So we're having f of x, f prime of x, and f prime prime of x. So this is the second step. The second step is actually performing the operation now. F of x is 1 plus x alpha. F prime of x, we have to derive it using this method we have. So we have alpha 1 plus x alpha minus 1. Doing the same thing again, because this is a constant. You know, if you're deriving a constant, you are deriving and you have a constant, you can actually bring the constant outside the derivative and work with what you have. And in this case, we are left with 1 plus x alpha minus 1. So alpha minus 1, 1 minus x alpha minus 2. The third step is replacing with 0. So replace with 0. 1 plus 0 is 1 raised to the power of alpha, and 1 raised to the power of anything, you know, it gives us 1. Okay, we apply it here again. I replace this with 0, so I'm left with 1 raised to the power of alpha minus 1. 1 raised to the power of anything, which will give us 1. 1 times alpha, that's alpha. For f prime prime of 0, I have 1 plus 0, which will also give me 1. 1 times this is going to, I'll be left with this. So at this stage, we already know what our f of 0 is, our f prime of 0, and our f prime prime of 0. What we do now is to just replace it back into our formula, and that's all. Yes. So going to the fourth step. The fourth step is now putting it back into the formula. So replacing in the formula, the fourth step, replacing in the formula. We now have f of x. Let's write back our formula just so we'll be sure. always missing out there. F prime of 0 plus x squared over 2 factorial f prime prime of 0 plus x squared epsilon of x, where the limits when x tends to 0 of epsilon of x is equal to 0. Now we already know what our f of 0 is. It's alpha. Our f prime of 0, f of 0 is 1. F prime of 0 was alpha. Our f prime prime of 0 was alpha, alpha minus 1. So we'll just have to replace it here. We clean this and replace it with 1, because that's what our f of 0 is. 1. This alpha and for this one it was alpha, alpha minus 1. And x of 2, x raised to the power of 2 plus it, that plus x raised to the power of 2 epsilon of x, where the limit when x tends to 0 of epsilon of x is equal to 0. And this is the dl of 1 plus x raised to the power of alpha. So that's how it works using the Mac-Laurin formula. For Mac-Laurin formula, we already said we use it when we are going to like the voisinage of 0 when x is equal to 0. So that's when we are allowed to use the Mac-Laurin avec Young formula. But I want us to take attention. Okay, I'll write it here. A function can have a DL without having to apply the Mac-Laurin avec Young formula, which will be seen in subsequent videos. So in our next video, like I already said, we'll be discussing the operations used in DL and some general DLs and then other methods used in DL, before we get to my favorite part, which is tackling exercises. So please, if you have not subscribed to my channel Nejma Test, you can just click the subscribe button below. Thank you and see you in the next video.